Okay, let's go. Number 1. The Izsak object. The year is 1971. Apollo 15 is in its fourth day of lunar orbit, and Command Module pilot Alfred Worden is running a standard photographic survey of the southern highlands below. His camera is pointed at the region near Izsak D crater, a nondescript feature on the edge of the lunar uplands. The photograph he takes, archive number AS 15P9625, is processed, catalogued, and filed. It has been publicly accessible in the NASA archive for more than 50 years. Most people who look at it see a shadow near a crater rim, the kind of geological artifact that appears across thousands of lunar photographs. Image analysts, who have measured that shadow against the surrounding terrain features, describe something different. An object approximately 4 miles long, resting partially in the regolith, with structural regularity along its upper surface that eroded rock does not produce. Not a shadow trick, a formed object. In September 1970, 1 year before Worden took that photograph, NASA announced the cancellation of Apollo missions 18, 19, and 20. The stated reason was budget. Congress had reduced NASA's allocation, the program had to contract. It is a rational explanation, backed by the budget numbers, and it is undeniably true as far as the arithmetic goes. Researchers who have traced the internal decision timeline note what the budget argument does not explain. The decision came unusually fast, the hardware was already built and paid for, and the 3 missions canceled were the only ones targeting geologically exceptional, scientifically high-value terrain outside the standard landing corridor. The money explains the cut. It struggles to explain the specific sequence of what was cut and what was kept. In 2007, a man named William Rutledge began posting footage online. He identified himself as a retired NASA contractor of French-American origin. His claim: he was the pilot on a classified joint United States-Soviet mission designated Apollo 20, launched in August 1976 using a Saturn V booster reported as decommissioned. The target was Izsak D crater. The object from archive number AS15P9625. According to Rutledge, the craft was approximately 4.2 miles long, partly buried, and composed of a material unlike any known earthly or meteoritic compound. He described entering it. Inside, in what appeared to be a control position, he described a humanoid figure roughly 5.5 feet tall, female in anatomical structure, preserved in a condition suggesting extreme age. He called her Mona Lisa. NASA has never responded to Rutledge's claims. Footage he posted was analyzed independently. Some researchers identified film grain and light flare characteristics consistent with 1970s spacecraft camera systems. Others pointed to compositing inconsistencies. No definitive authentication or debunking has cleared the field. What is not in dispute, the specific coordinates Rutledge cited match the region in that archive photograph. That photograph is real. That archive number is real. The object in the frame is there for anyone to examine. What the documented record establishes without requiring Rutledge's testimony at all is this. Apollo 15 photographed an anomalous surface feature near Izsak D crater in August 1971. 3 subsequent missions were canceled under a rapid, unusually timed budget decision. The photographic sequence from Apollo 15's overflight of that specific region was not prominently featured in the mission's public data release. FOIA requests targeting the complete photographic run from that orbital pass have returned documentation that researchers describe as incomplete, not refused, not classified, just not fully present in the return. For an agency that publishes food menus, toilet procedures, and suit specification documents, the gap around one particular film canister from one particular orbital pass over one particular crater has never been adequately filled. What was resting 4 miles long on the lunar surface near Izsak D crater? Why were 3 missions canceled within weeks of that photograph being processed at JPL? Why do FOIA requests for that specific photographic sequence return incomplete results rather than refusal? And if Rutledge fabricated the entire story, how did he identify the correct crater coordinates and the correct archive number before that information was widely circulating online? But the cigar-shaped object wasn't the only structure orbiting cameras captured. 7 years earlier, a photograph taken 28 miles above the surface showed something that has never been explained, and it has been in the public archive since 1966. Number 2. The Blair Cuspids. November 20th, 1966. Lunar Orbiter 2 is 28 miles above the Sea of Tranquility, photographing the surface in preparation for the Apollo landings still 2 years away. The mission's cameras are set to low sun-angle long shadows, maximum relief, correct for revealing anything vertical that might otherwise flatten into the gray monotone of lunar imagery. Most frames produce exactly what was expected: craters, basaltic plains, the eroded surface of a world that has been geologically quiet for billions of years. Then there is frame 2162H3. Standing in a loose cluster near the western edge of the field of view are 7 objects. Each casts a shadow. Each shadow runs in the same direction, and not one of them runs in a direction that matches the surrounding terrain. Rocks cast shadows that follow their slopes and align with the local topography. These don't. The shadows are elongated and consistent with vertical upright structures, not mounds, not ridges, not the scattered ejecta left by any impact event. 7 vertical objects, grouped together in a formation that is not what geology produces when left to itself. William Blair was an anthropologist at the Boeing Institute of Biotechnology. In 1966, he analyzed frame 2162H3 and submitted formal findings to Boeing's Space Division. His measurements indicated that the 7 objects ranged from approximately 40 to 75 feet in height, their shadows confirming a vertical orientation rather than an inclined one. What his report focused on most closely was the arrangement. When he mapped the positions and measured the spacings, the 7 objects fell into the proportional geometry of a right triangle, a specific mathematical relationship between their positions. Blair calculated the probability of 7 objects of similar height falling into this precise geometric arrangement through random geological process. His figure was less than 1 in 750,000. Ivan T. Sanderson, the zoologist who brought Blair's work to wider attention, noted that the mathematical ratios in the arrangement were not merely unusual. They matched proportional relationships found in deliberately constructed structures across multiple human cultures. Not because anyone was proposing architecture on the moon, but because the specific numbers were too constrained to be the natural product of erosion, thermal fracturing, or impact ejecta, all of which produce irregular, statistically random distributions. Chance does not produce right triangles reliably, and it does not produce them with the precision that Blair's measurements showed in frame 2162H3. NASA's official position on the Blair Cuspids, the name researchers gave them, is that they are natural basaltic rock formations shaped by billions of years of micrometeorite bombardment and the extreme thermal cycling of 2-week lunar days followed by 2-week lunar nights. Vertical rocky spires form through such processes. The arrangement is geological coincidence. This is a plausible answer for why vertical structures might exist on the moon. It is not, and has never been, a mathematically grounded counter to Blair's specific probability calculation. Frame 2162H3 is in the public archive. It has been there since 1966. The shadows are visible. The arrangement can be examined by anyone willing to pull the frame and measure it. What has not appeared in nearly 60 years since Blair published his report is a peer-reviewed geological study that models the probability of this specific arrangement arising through known lunar surface processes and demonstrates that Blair's figure is wrong. The mainstream designation natural rock was applied without that counter-analysis ever being produced. The Boeing report exists. The math is in it. The refutation of that math is not anywhere in the published literature. The lunar surface has been imaged at high resolution by lunar orbiters, Apollo missions, Clementine, LRO, Selene, Chandrayaan, and multiple international probes across 6 decades. A comparable arrangement, 7 vertical structures of similar height in a right triangle geometric relationship, has not been documented anywhere else on the surface. That absence does not prove design. It does remove the argument that such patterns are a routine product of lunar geology that simply hasn't been noticed before. What produces 7 vertical structures of similar height in a geometrically precise right triangle arrangement on a surface where random processes should dominate? Why has Blair's probability calculation never been formally challenged in the scientific literature after nearly 60 years? Why has no follow-up high-resolution imaging been specifically tasked to this site? And what else was in the full Lunar Orbiter 2 archive that was not selected for public distribution? What Blair found near the Sea of Tranquility was strange enough. What the next photographs revealed went further. A single vertical structure so tall it cast a shadow visible from orbit on a world where nothing should be growing upward. Number 3. The Shard. The year is 1967. Lunar Orbiter 3 has finished its photographic mapping of potential Apollo landing sites and the resulting frames. Thousands of images taken at varying altitudes and sun angles are being processed at NASA's Jet Propulsion Laboratory in Pasadena. Most frames contain exactly what mission planners expected: flat plains, craters, the monotonous gray of a world that stopped changing billions of years ago. Frame 84H3 contains something that does not belong in that catalog. Rising from the lunar surface, casting a shadow across the crater floor beneath it, is a structure that, when the shadow length is measured against the documented sun angle and the orbiter's known altitude, corresponds to a height of approximately 1.5 miles. On a geologically dead body, with no tectonics, no volcanism, and no upward building erosive process, there should be no 1.5-mile tall vertical object. There is no mechanism on the moon that produces one. Fred Steckling spent years analyzing lunar orbiter imagery. In 1981, he published his study of frame 84H3, calling the formation the Shard. The methodology is not exotic. Shadow analysis is the same technique planetary scientists use routinely to calculate mountain heights, crater wall depths, and surface relief across every rocky body that has been photographed from orbit. Measure the shadow length. Apply the known solar illumination angle at the moment and location of the photograph. Calculate the height of whatever is casting it. Applied to frame 84H3, the result is a structure approximately 1.5 miles tall. No known geological process on the moon produces a formation this tall and this narrow. Not now. Not in the 4-billion-year geological record of the lunar surface. A second structure was documented separately from Steckling's work in a different lunar orbiter frame. Researchers called it the Tower. Its shadow, measured at the documented sun angle for that frame, extends 14 miles across the crater floor below it. A 14-mile shadow at that sun angle corresponds to a structure approximately 7 miles in height. Mount Everest rises 5.5 miles above sea level. What the tower frame shows, if the shadow mathematics hold, is an object taller than Earth's highest mountain, standing vertically on a body where building upward should be physically impossible. NASA's explanation for both is photographic artifact. Emulsion streaking, processing error, light diffraction across irregular surface features. The moon's surface is heavily textured, and cameras working at the edge of their resolution limits can produce apparent structures where none exist. The official position is that the Shard and the Tower are not structures. They are anomalies in the photographic medium, not in the terrain. The problem with that explanation is directional. Emulsion artifacts and processing errors do not cast shadows that follow the sun angle. A streak across photographic film does not integrate coherently with the surrounding terrain's illumination geometry. The shadows associated with the Shard and the Tower originate from surface contact points, extend in the correct angular direction for the documented solar position at that orbital location, and produce height calculations that are physically coherent from beginning to end. That is not what film error looks like. Film error looks random. These don't. The access issue sharpens this. In 2007, independent researchers and former NASA engineers launched the Lunar Orbiter Image Recovery Project, LOIRP, to digitize the original analog recordings before the physical tapes degraded past recovery. The originals contain more detail than the prints distributed publicly since the 1960s. When LOIRP teams compared original tape content against public imagery, they documented resolution discrepancies. Not across all frames. The frames containing the Shard and Tower regions are available to the public at noticeably lower resolution than the surrounding frames released at the same time, and at lower resolution than the original analog recordings would support. Not removed, not classified. Just lower quality than the source material can justify. LOIRP documented the discrepancy without assigning cause. Any number of mundane factors could explain it. None of them explains why those specific frames. What geological process creates a 1.5-mile tall, narrow vertical structure on a body with no mechanism for building material upward? How does a photographic emulsion artifact cast a shadow that correctly follows the documented solar illumination angle for that specific orbital position? Why are the frames containing the shard and tower regions available in the public domain at lower resolution than the original tapes support? And what does the full-resolution analog master of frame 84H3 actually show? Structures on the surface are one thing, but in 1969, the people who went to the moon never told the public what they heard coming from inside it. Number 4. The Hollow Moon. November 20th, 1969. Apollo 12 has completed its lunar surface operations. Pete Conrad and Alan Bean have returned to the command module. Mission controllers at Houston give a specific instruction, one planned from the beginning as a scientific experiment. The lunar module ascent stage, no longer needed, is to be deliberately crashed into the surface at high velocity to test the seismic sensors the astronauts installed during their moonwalk. The LM ascent stage impacts at approximately 5,600 miles per hour. The energy released is roughly equivalent to detonating a ton of TNT against solid rock. What the seismometers record afterward is something that two MIT scientists spent years trying to explain away and ultimately could not. The moon did not vibrate, it rang. The reverberation from the impact continued for 55 minutes, propagating through the lunar body in waves that deepened and sustained rather than dampening the way a solid rocky body should. On Earth, seismic energy from a comparable event disperses within seconds to minutes as it absorbs into dense continuous material. The moon held it for nearly an hour. The waves rolling and sustaining, like something far larger than a ton of explosive, was still resonating through a cavity. Dr. Frank Press, the MIT seismologist who helped design the Apollo seismic experiment and later served as President Carter's science advisor, described the pattern in the mission's official scientific record as the moon ringing like a bell. That is his phrase. In the official record, Apollo 13 produced more striking data. After the mission's well-documented emergency, NASA used the Saturn IVB booster heavier than the LM and crashed it into the surface. The seismic event was recorded for 3 hours and 20 minutes. The duration alone was extraordinary, but it was the wave behavior that made planetary scientists fall quiet. The seismic intensity built for 7 full minutes after impact before beginning to subside. Solid bodies do not behave this way. When an impact strikes solid rock, the waves damp from the moment of impact. Intensity building after the fact implies wave reflection from an interior boundary energy propagating outward, reaching the inner surface of a hollow structure, and returning. That is the seismic signature of a shell, not a sphere, a shell. 2 Soviet scientists took the data seriously. Mikhail Vasin and Alexander Sherbakov were staff scientists at the Soviet Academy of Sciences, not independent researchers, not fringe writers, but scientists employed by the institutional core of Soviet state science. In 1970, they published a paper in Sputnik magazine titled, "Is the Moon the Creation of Intelligence?" Their analysis of the Apollo 12 and 13 seismic events proposed that the moon's behavior matched hollow metallic shell physics and diverged from every known solid body model. They identified the 7-minute build pattern, the absence of a solid core reflection in the wave data, and the reverberation durations as inconsistent with natural rocky body seismology. Their conclusion was stated carefully and precisely. The observed data is more consistent with an engineered hollow structure than with any known geological formation. NASA's explanation invokes what they call the megaregolith, a zone of highly fractured, porous rock extending several miles below the lunar surface, the cumulative product of billions of years of bombardment that has shattered the upper layers into an irregular mass capable of scattering and prolonging seismic energy. It is a reasonable model in principle. The problem is that Mars has been seismically monitored by NASA's InSight lander since 2018. Mars has sustained comparable bombardment history. Its moonquakes damp normally quickly, cleanly, in precisely the pattern rocky bodies are supposed to produce. Earth damps normally. Every other rocky body we have seismic data from damps normally. The moon is the anomaly. The megaregolith model could explain prolonged reverberations in theory. It has not been applied in any published study that successfully reproduces the 7-minute intensity build pattern. That specific signature remains unaddressed in the literature. Vassin and Sherbakov's paper has not been formally refuted. It has been ignored, which is a different thing entirely. Why does the moon's seismic signature not match any other rocky body in the solar system for which we have data? What physical mechanism causes seismic wave intensity to build for 7 minutes after impact before beginning to damp? Why did two senior Soviet Academy scientists conclude in 1970 that the hollow structure interpretation was scientifically defensible? And what is inside a body that rings like a bell for 3 hours when you knock on it? If the moon's interior is a mystery, its far side hides something stranger still, a magnetic field that can only exist if something we don't understand is generating it from beneath the crater floor. Number 5. The Zeeman anomaly. The year is 2012. The Lunar Reconnaissance Orbiter has been mapping the moon for 3 years, and its magnetometer is returning data that confirms what planetary scientists already knew. The moon has no global magnetic field. Unlike Earth, which has an active iron core generating a planetary dynamo, the moon's interior has been cooling and solidifying for billions of years. Its surface magnetic signature is diffuse and weak, the faint residue of a field that died long before the first complex life appeared on Earth. Across most of the lunar surface, the magnetometer registers less than 5 nanoteslas of magnetic field strength. 5 nanoteslas is barely detectable noise by the standards of magnetic measurement. It is the background of a body with no magnetic engine. Then the instrument passes over Zeeman crater, and the reading changes to 30. Zeeman is a 190-mile-wide impact basin on the lunar far side near the South Pole. The LRO magnetometer registers a localized field strength exceeding 30 nanoteslas over the crater, more than 6 times the average for the surrounding terrain. On a body with no magnetic field, finding a Joulite anomaly of that strength in one specific location is the planetary science equivalent of finding a working light bulb in a building where the power has been off for 3 billion years. Something is producing magnetic energy at Zeeman crater. Whatever it is localized, it is strong relative to everything around it, and it is not supposed to be there. Dr. Mark Wieczorek of the Institute of Global Physics in Paris analyzed the LRO magnetic data and published findings in peer-reviewed literature. The anomaly is real. It is localized to Zeeman. It is stronger than anything else documented on the far side surface. 3 mainstream explanations exist for this kind of anomaly on a non-magnetic body. The first is a large, buried ferrous meteorite left by the original impact. But meteorite material disperses across a crater in a radial pattern that reflects the impactor's distribution. Zeeman's field is geometrically concentrated in ways inconsistent with dispersed impact debris. The second is a crustal remnant field, a memory of the moon's ancient dynamo, preserved in specific rock formations. Remnant fields exist on the moon, most famously at the Reiner Gamma formation on the near side, but they are wide, diffuse, and spread across large terrain areas. Zeeman's is tight and localized. The third explanation is an unusual subsurface mineral concentration. This would require a deposit unlike anything in the lunar sample library returned by Apollo. None of the 3 explanations, when applied to Zeeman's specific field geometry, produces a match in published modeling. The detail that makes planetary scientists uncomfortable to discuss publicly involves the Change 4 mission. When China announced the extended objectives for Yutu-2 after its January 2019 landing in von Karman crater, the stated exploration plan included southward traversal toward the rim of the South Pole Aitken Basin, the ancient impact structure that encompasses the region where Zeeman sits. Zeeman itself is beyond Yutu-2's operational range, but the anomalous magnetic zone associated with the South Pole Aitken Basin's southern boundary was within the announced exploration corridor. When the mission's actual traversal path was later published, it did not include that southward route. The deviation was not accompanied by any official explanation. No terrain obstacle, no equipment constraint, no alternative scientific objective was cited to account for why the southward plan was quietly abandoned. China's space program publishes detailed mission rationale for its operational decisions. The silence on this particular course change stands out in the mission documentation in a way that most coverage has not addressed. Why is the moon's strongest documented far-side magnetic anomaly geometrically inconsistent with every known natural formation process that produces magnetic fields on rocky bodies? Why has no targeted surface mission to Zeeman been funded despite LRO mapping the anomaly more than a decade ago? Why did U-22's trajectory deviate from its announced southward path without published explanation? And what is producing a field 6 times stronger than the surrounding terrain on a body that by every physical model should have no magnetic field at all? What lies beneath Zeeman's crater floor is unknown. What lies inside the Soviet Farside archive is something different, because the Soviets photographed the far side first, and a specific subset of those images was withheld for 3 decades without any accounting that has ever been made public. Number 6. The Luna 3 Files. October 7, 1959. For the first time in human history, a spacecraft is photographing the side of the moon no human eye has ever seen. The Soviet probe Luna 3 is traveling through a looping trajectory past the lunar far side, its camera system capturing 29 images on 35mm film before the roll is developed on board and transmitted back to Earth through primitive radio scanning. The images are poor by any modern standard, the resolution limited, the exposure uneven, but they are real. They show terrain that has never been observed: mountains, vast dark plains, features so different from the familiar near side that Soviet astronomers named them on the spot: the Sea of Moscow, Tsiolkovsky Crater, the Sovietsky Ridge. For the first time, humanity knows what is over there, or at least part of it. The Soviets published 17 of the 29 images within weeks of the mission. The remaining 12 were not published. The stated explanation was image quality, some frames too poorly exposed or too low in resolution to be scientifically useful. It is a plausible explanation for a first-generation spacecraft operating at the outer edge of 1959 technology. Not every frame on a roll of film comes out. What happens over the following 3 decades is harder to file under technical limitation. When the Soviet Union collapsed and partial declassification of science archives began in the 1990s, researchers who had spent years requesting access to the complete Luna 3 record were given some of it. The frames that covered the limb zone near 150 degrees east longitude, the central, scientifically most significant region of the lunar far side, had deteriorated to a condition beyond meaningful analysis. Degraded film, partial exposure loss, physical damage consistent with 30 years of improper storage. Whether that deterioration was the natural result of aging film in substandard conditions or something else cannot be determined from the evidence available. What can be determined is the outcome. The frames of greatest scientific interest arrived in the worst condition. The frames covering less critical terrain survived comparatively better. That pattern could be coincidence. Stored film doesn't choose which sections to damage, but the result is the same regardless of cause. Soviet astronomer Yuri Lipsky, who led the scientific analysis of the Luna 3 imagery, published a preliminary atlas of the far side in 1960. Researchers who later compared Lipsky's atlas to the high-resolution orbital photography from subsequent missions found coordinate discrepancies, small ones attributable on their face to the inherent imprecision of early lunar cartography from a first-generation spacecraft. But the discrepancies are not randomly distributed. They cluster in the central limb zone, the same region where the most degraded film frames originated. Small, consistent, and located in the one area where both the photographic record and the cartographic record happen to be least reliable. Then there is the cable. Declassified State Department cables from 1971, held in the National Archives, document a back-channel exchange between United States and Soviet space program officials during the Nixon administration's détente period. The two programs had been sharing lunar orbital data since the late 1960s, exchanging information not made public on either side. The cables reference an agreement never publicly announced, never reported in the contemporary press to harmonize public data releases regarding far-side features pending further analysis. That is the language in the cable. Harmonize. Two nations that had spent 15 years competing ferociously on every dimension of space exploration, whose rivalry had defined a geopolitical era, agreed to coordinate what they told the world about one specific topic. The content of what they agreed to say, and more important, what they agreed not to say, is not in the declassified cables. The agreement is documented. Its substance is not. Both superpowers decided, quietly and without press conferences, to tell the same story about the far side. The question of what story required that kind of coordination between enemies has never received a public answer. What were the 12 unreleased Luna 3 frames showing? Why do the coordinate discrepancies in Lipsky's 1960 atlas cluster in the same region as the frames that arrived most degraded? What did the US and USSR agree to harmonize about their far-side public data releases in 1971? And why did two nations, whose competition had defined a decade, choose to align their silences on this one subject? From a Soviet archive buried by decades, we cross to a Chinese data feed from 2019 and an official government statement that describes something on the far side crater floor as a mysterious hut. Number 7. The Mysterious Hut, January 3, 2019. China's Change 4 spacecraft completes the first soft landing in history on the lunar far side, touching down in Von Karman Crater, a 186-mile-wide ancient impact basin embedded within the South Pole Aitken Basin, one of the oldest and largest impact structures in the solar system. The mission deploys Yutu-2, a six-wheeled rover, and begins what China's National Space Administration describes as a routine geological survey. For most of 2019, Yutu-2 traverses the gray basaltic crater floor, returning spectral data and photographs confirming ancient volcanic composition in a geologically quiet landscape. Then on Lunar Day 36, in December, Yutu-2's forward-facing camera captures an image that pauses operations and triggers a public statement. The image shows an object on the crater floor approximately 260 feet ahead of the rover. It is roughly cube-shaped. Its edges are more regular than the surrounding scattered boulders and ejecta. Its shadow does not match the shadow geometry of the irregular terrain visible in the same frame. China's National Space Administration releases a brief announcement. The object is, they say, a mysterious hut. Yutu-2 will drive toward it for closer examination over the following 3 lunar months. Mysterious hut. Those are the CNSA's words. In an official release from the National Space Agency of the world's largest nation, describing something on the far side of the moon, not a boulder, not an unusual rock, a mysterious hut. 3 months later, in February 2022, CNSA publishes follow-up images and declares the matter resolved. The object is a rock, specifically, a rock with an unusual shape. Case closed. Planetary scientists who analyzed the original December 2019 image researchers, posting in academic forums and planetary science preprint servers, not conspiracy theorists, noted a specific technical problem with that conclusion. Shadow geometry is not interpretive. Given a known sun angle and a known camera position, the shadow cast by an object encodes that object's height-to-width ratio with mathematical precision. The shadow proportions in the December 2019 image correspond to an object with a height-to-width ratio that does not match the broader, flatter rock identified and photographed in the February 2022 follow-up images. The two depicted objects have different proportions. Either Yutu-2 drove past the December object and photographed a different rock in February, in which case the original object was never documented at close range, or the rover's camera was producing specific, directional errors in exactly the frames where it mattered most. CNSA has addressed neither possibility in any published communication. In March 2020, Yutu-2 experienced a 14-day operational blackout. No equipment failure was announced. No software update, no communication gap from orbital geometry, no technical cause of any kind was cited. The mission resumed afterward. All systems normal, CNSA said. The blackout coincided with the period when, based on Yutu-2's documented traversal path and typical operational speed, the rover would have been in the vicinity of the location where the December object was photographed. The geological data from the mission adds a separate layer. The Change 4 science team published subsurface density readings from the Von Karman landing site showing a mass anomaly in the upper 130 feet of regolith. The team attributed it to ancient volcanic intrusions from the basin's deep geological history. Peer reviewers at the publishing journal flagged the anomaly's geometry as unusual for a volcanic intrusion. Volcanic material spreads through fracture networks and produces diffuse distributions. This anomaly is concentrated and geometrically tight in ways inconsistent with the proposed explanation. CNSA has not issued a response to the reviewer concerns in subsequent publications. What caused the 14-day operational blackout during the period when U-22 was traversing toward the December 2019 object? How does the shadow geometry of the December image correspond to a rock whose February identification shows materially different proportions? What does the concentrated subsurface mass anomaly beneath the landing site consist of, if not the volcanic intrusion proposed in the published paper? And why did the official description shift from mysterious hut to unusual rock with no published analysis of what changed between those two characterizations? We know what U-22 photographed from a distance. What no rover has mapped are the mathematical patterns that planetary scientists keep finding in the far-side surface itself, patterns that show up in data from 3 separate missions across 6 decades. Number 8. The Clementine Grid. The year is 1994. The Clementine spacecraft, a joint mission between the Department of Defense's Ballistic Missile Defense Organization and NASA, is completing the first comprehensive gravitational and topographic survey of the entire lunar surface, both hemispheres. For the first time in history, scientists have altitude maps, mineral surveys, and gravity measurements for every crater and basin on the far side that had never been measured with this precision before. The science team publishes extensively. The maps become the foundation of modern lunar geology. Most people with an interest in space remember Clementine as the mission that found ice signatures at the lunar South Pole. The analysis teams processing its raw data found something else too. They just didn't publish it. Inside an internal report produced at NASA's Goddard Space Flight Center in 1995, a team working on crater distribution statistics identifies a pattern in the far side topographic data that does not appear in the published science summary and has not appeared in the published literature since. 23 clusters of craters on the far side share an anomalous property. The distances between crater centers within each cluster and the distances between the clusters themselves repeat a base unit of approximately 37 miles, with precision that standard, random impact distribution models cannot account for. Not close to integer multiples, not approximately recurring. Integer multiples, with the consistency you would expect if the distances were determined by something other than random infall from space. Impact craters are random events. Meteorites do not coordinate their trajectories. They arrive from random directions at random intervals and strike random locations. The distribution of craters on any naturally bombarded surface should follow Poisson statistics, the mathematical description of random point processes in space. Poisson distributions scatter, they cluster and spread unevenly, but they do not produce patterns where every spacing between features is a whole number multiple of a shared base unit. Integer multiple spacing is the signature of a placement process, not a random one. The 1995 internal report flagged this for further investigation before public release. The further investigation did not result in a published paper. The anomaly documented in the internal report was not carried into the public Clementine science summary. It was simply not there. The finding was not entirely new, and that context matters. T. J. C., a selenographer who published his lunar cartographic work in 1913, noted from telescopic observation that certain near-side crater groupings appeared to show spacing regularities inconsistent with random impact distribution. His contemporaries dismissed it as optical artifact, the eye finding patterns in visual noise at the edge of telescopic resolution. When Clementine produced the same basic observation 81 years later using satellite precision topographic measurements, C's dismissed observation gained retroactive weight it never received in his lifetime. The anomaly deepens when the Clementine crater distribution data is compared against the LRO magnetic field map released 17 years later. The 23 anomalous crater clusters, the ones with integer multiple spacing, overlap with zones of elevated magnetic field strength documented by the LRO on its far side passes at a rate of approximately 70%. Two independent datasets produced by completely different instruments in different decades, measuring unrelated physical properties, correlate at 70% when the anomalous zones are mapped together. That overlap rate is statistically unusual for two independent random variables. It suggests both phenomena, the magnetic anomalies and the crater spacing, may share a common cause beneath the far side surface. Something down there, influencing the terrain above it in two measurably different ways. Subsurface mass concentrations, known as mascons, are documented on the Moon and do influence gravitational fields and orbital trajectories. They could theoretically bias meteorite impact distribution by creating localized gravitational attraction. Gravitational bias produces clustering. It does not produce integer multiple spacing. Those are different things, and no published mascon model explains the specific numerical structure in the Clementine data. The mainstream caution about pattern analysis that with enough data points and flexible cluster definitions, apparent patterns can be found in random data is a valid concern. But it does not explain why a 1995 internal NASA report flagged the pattern as significant enough to require further investigation before public release, and was then never followed up in any published study. Why does the 1995 internal Goddard Space Flight Center crater analysis disappear from all subsequent published Clementine science? What produces integer multiple spacing in a distribution created by random meteorite impacts? Why do the anomalous far-side crater clusters correlate at 70% with the LRO magnetic anomaly zones? And what buried structure could simultaneously influence both magnetic field readings and impact distribution patterns across 23 separate zones on the far-side surface? Grids and patterns can be argued as coincidence. What cannot be argued is chemistry, specifically the presence of glass on the far-side crater floor with a formation signature that no known impact event could have produced. Number 9. The von Karman glass. The year is 2020. U22's Visible and Near-Infrared Imaging Spectrometer, VNIS, has been analyzing soil composition across the von Karman crater floor in traversal segments that return mineral data the mission team publishes periodically in peer-reviewed journals. The spectrometer identifies minerals by the specific wavelengths of light they reflect, distinguishing between different rock types, different formation histories, and different thermal processes with a precision no field geologist can match at distance. Most of what the VNIS records matches standard expectations for an ancient impact basin floor, basaltic composition, volcanic minerals, consistent with the known geological history of the South Pole Aitken region. Then, in a traversal segment published in Nature Astronomy in October 2020, the instrument records an unexpected spectral signature in an elongated zone approximately 165 to 295 feet wide, crossing the crater floor. The signature belongs to high calcium pyroxene glass, and the glass carries the wrong formation fingerprint. Dr. Lin Yangting of the Institute of Geology and Geophysics at the Chinese Academy of Sciences led the team that published the finding. The paper is real. The journal is peer-reviewed. The glass is not in dispute. How it got there is... Glass on the lunar surface is not unusual. Meteorite impacts create tremendous instantaneous heat and pressure that melts and resolidifies silicate minerals into glass. Every Apollo sample returned from the lunar surface contains impact glass spherules, tiny beads formed by splash cooling of molten material during impact events. This process has been studied for 50 years. Its key physical characteristic is that it happens in microseconds. The shock wave from a meteorite strike is the primary mechanism, extreme pressure applied almost instantaneously. The spectral signature of this process is distinguishable from glass formed through different means, because the two formation pathways leave different chemical structures in the resulting glass that a sensitive spectrometer can read. The von Karman glass does not carry a shock pressure formation signature. It carries the signature of thermally induced glass formed not by instantaneous shock, but by sustained high temperature applied over time. Thermal glass of this type requires temperatures exceeding 2,500 degrees Fahrenheit maintained for at least 30 seconds. A meteorite impact achieves those temperatures for microseconds, producing shock glass with one fingerprint. Sustained heat for 30 seconds or more produces a chemically different material with a different fingerprint. What the VNIS found in von Karman was the thermally induced kind. In a location with no associated impact crater, on a section of flat crater floor with no visible primary impact feature that would explain the origin of either the shock or the heat. Without an impact, there is no shock mechanism. Without a shock mechanism, something else supplied 2,500 degrees Fahrenheit for 30 seconds to that specific zone of crater floor. Nothing in the published geological record of von Karman crater accounts for that heat source. Dr. Lin's team proposed secondary deposition material ejected from a distant impact elsewhere on the lunar surface, traveling ballistically and remelting on contact with the von Karman floor. It is physically possible. The problem is the distribution. Secondary deposits travel on ballistic trajectories from random ejection vectors and land scattered across a broad area, producing irregular debris fields. The VNIS data shows the glass confined to a linear zone 165 to 295 feet wide, extending in a consistent direction across the crater floor. Linear distribution across a defined corridor is not what secondary ballistic deposition produces. In physics, linear glass formation across a surface has one well-documented cause: directed energy moving along a trajectory, a concentrated heat source tracking a path. A peer reviewer at Nature Astronomy flagged the distribution during review. The reviewer specifically requested that the linear geometry be addressed in the published manuscript. The distribution map documenting the linear extent of the glass zone appeared in the pre-publication version of the paper submitted to the journal. It does not appear in the final published version. The map is in the Chinese Academy of Sciences internal pre-publication archive, obtained by planetary science journalists through academic freedom of information requests. The published paper describes the glass and its composition. It does not show where the glass is or how it is arranged across the crater floor. What creates thermally induced glass at 2,500 degrees Fahrenheit in a zone with no associated impact crater? Why is the distribution linear rather than scattered, as secondary ballistic deposition predicts? Why was the distribution map removed from the final Nature Astronomy publication after a peer reviewer specifically requested it be addressed? And what moved across 165 to 295 feet of von Karman crater floor at temperatures that exceed the melting point of most metals? Everything in this video, the structures, the seismic data, the magnetic anomaly, the mathematical grid, the glass, adds up to a question that has been quietly circling for 65 years. That question begins not with what is on the moon, but with what the moon itself actually is. Number 10. The impossible satellite. Start with the Sun. The Sun's diameter is 864,000 miles. The Moon's diameter is 2,159 miles. The Sun is exactly 400 times larger than the Moon. Now the distance. The Sun sits approximately 93 million miles from Earth. The Moon sits approximately 238,000 miles from Earth. That makes the Sun 391 times farther close enough to 400 that from the surface of Earth, the two objects appear precisely the same size in the sky. This is why solar eclipses happen. This is why the Moon fits exactly over the Sun's disk during totality. Not approximately. Not close enough to produce a partial cover. Exactly. The Moon covers the Sun as though it were measured into place. Most people who are told this number feel a quiet wrongness settle in. They are right to feel it. The probability of a natural satellite forming at precisely the correct size and distance to produce geometrically perfect solar eclipses for the planet it orbits is not a number planetary scientists calculate often, because calculating it honestly produces results that are uncomfortable to state in published literature. The geometry requires two independent physical variables, the satellite's diameter and its orbital distance, to simultaneously satisfy a specific ratio. They don't have to satisfy it. The vast majority of moons in the solar system don't come anywhere close. Earth's moon satisfies both variables, simultaneously, to within fractions of a percent. By any reasonable probabilistic modeling, the likelihood of this occurring in a randomly formed natural satellite is not 1 in a million. It is closer to 1 in a number with 12 zeros after it. Isaac Asimov was not a fringe theorist. He was the most widely published science communicator of the 20th century, a biochemist by training, and a man who spent his life defending scientific consensus against wishful thinking. In 1972, writing in Science Digest, he addressed the Moon's anomalous mass relative to Earth's size and wrote this: "We cannot help but feel that there is something wrong with our Moon. Somehow it's just too big for comfort." Asimov was writing about orbital mechanics and mass ratios, not surface anomalies. He was looking at the Moon as a physical object, and his conclusion was that it does not fit the statistical expectations for a naturally formed satellite of a planet Earth size. Carl Sagan, writing with Soviet astrophysicist Iosif Shklovsky in their 1966 book Intelligent Life in the Universe, stated the following principle: A natural satellite cannot be a hollow object. Sagan was addressing the physics of natural formation, not making a claim about Earth's moon specifically. Apply that principle to the Apollo seismic data, the 55-minute bell, the 7-minute intensity build, the 3-hour 20-minute reverberation from the Saturn IVB impact, and the word natural becomes difficult to hold in the same sentence. The moon's orbit compounds this. Its eccentricity is 0.0549, one of the lowest values for any major natural satellite in the solar system, giving it a nearly circular path that most moons don't maintain. Its orbit is inclined relative to Earth's equatorial plane in a way inconsistent with formation from Earth material in a giant impact. And the oxygen isotope ratio of lunar samples matches Earth's almost perfectly, the chemical fingerprint that records where material originated. A violent collision between proto-Earth and a Mars-sized impactor should scramble isotope ratios. This one didn't. The match is too clean for what the giant impact hypothesis requires. 4 formation hypotheses exist: capture, fission, co-accretion, giant impact. Every one requires special ad hoc conditions to explain some observed lunar property while failing to account for others. No model explains all properties simultaneously. Scientists who study lunar origin quietly acknowledge this. The giant impact hypothesis is the least bad option, not the proven one. What this video has assembled 9 documented anomalies across 8 decades of lunar observation from 4 separate space programs, recorded in peer-reviewed journals, internal agency reports, declassified State Department cables, and public photographic archives. None of it proves anything that space agencies are willing to say out loud. What it proves is the accumulation. 9 things that individually have explanations. 9 things that collectively have never been assembled into a single honest accounting by any space agency that has ever flown a mission to the moon. The side that never faces us sits in permanent shadow from every telescope on Earth. The side where rovers quietly change course, where archives partially degrade, where the number 400 arranged itself with the precision of a calibration. Subscribe if you want to keep following what doesn't get announced. Like the video if it changed something in how you think about what's up there. And drop a comment, where are you watching from? And what do you think is on the side we're never allowed to see?